with the stain, what Tim was explaining, which has both stains, the green and the red. So the green will show us the live ones, and the red, it will be very difficult to see on the screen, but if anyone is happy to come after the talk, look down the eyepiece, you can see the red and dim red through the eyepiece. So if we have a standard glove, and we cut this, I made that sample already and stored it in the microscope. The normal glove with the bacteria looks like, I'll show you how it looks like. So basically we see, this is the glove, this is green, and we see many green live bacteria. So that means that the standard glove doesn't have any effect on the bacteria. Now, if I'm taking the antimicrobial glove, I'll cut a small piece of this glove and place it on the slide. This will be a little bit slow because I need to be careful to use the right surface, which in the previous talk by Dr. Paul Wright was explained that the antimicrobial activity is on the outside of the glove. So therefore, I'm preparing a sample, and the sample should be facing upwards, where I will place the bacteria. So we've seen that they are all green. The red dye is present in that solution, so if bacteria suffer some treatment, then they start losing the green and the red will go in. So I'm loading the bacteria, one tiny droplet on the surface of the glove. So I have that reaction chain, what I said, the miniaturized experiment. The slide, the glove, droplet of bacteria, and I'm covering them. So note that there is some time delay in practice by assembling it. So that was the 0 time point when I loaded the bacteria. This process has started to work. And then in controlled environment, we illuminated the glove, the known light intensity to activate singlet oxygen production. But we know from the measurements that the available light still will create that activity. So, but in the laser experiments which we show you, so for example, the one to the right on that image, it was treated for 2 minutes like this. Basically, we use the torch. So just to reiterate, this was our control, standard glove, non-regular normal glove. I will switch it to the new slide. So you are seeing what I'm seeing. So this green is the antimicrobial glove. And that we don't see green bacteria means that we lost dye. Now, to show you that they're really here, the bacteria are here in the sample, further of that position, there's some yellowish weak bacteria. So the further I go from the glove, I see some bacteria, but they're not as bright as the normal glove was. So even that far, when I compress and put together the sample, I'm pushing away those which were started to be killed, so that the closest ones will be affected the most, and the further ones. So if we go back close to the glove surface, then we cannot see any living signs of those bacteria. So just to show you again, I'll show you again the standard glove.
So again, remember the bottom part, this here is the standard glove surface, and these are all the living bacteria still living next to this normal glove, the normal one you take out of the box. When Robert put on the AMG, the antimicrobial glove, you can see the bright surface of the glove itself, but anywhere near that, it was just black, this dot. No, the bacteria is still there, they've been killed, but there's no diet, so we've killed them by that block. So again, the glove has been moved around, so it's in a different position. This is now the antimicrobial glove. Glove surface, Robert's going to focus, you're moving across, you can't see anything. The bacteria have been killed. So when we conducted these experiments back in England, I remember on our confocal microscope, this kill was so rapid that by the time we loaded the bacteria onto there, put it onto the microscope, started scanning, the bacteria were killed. It was very, very quick.
So this is a dirt which will help me focusing. Yeah, like this. Then I see, when you will come here and look down the eyepiece, you will see some populations, but these are not absolutely green. Between the green ones, you see a lot of orange and pale red, which you can look down the ocular. I think that's the best way to see it. With the laser microscope, we can use a longer detection, and then we can extract all the red signal, and then that's measurable.